Hello everyone, my name is Bhakti Shinde and I am from Sri Siddheshwar Women's College of Engineering, Solapur. In this video, we are discuss about the process table and the process control block PCB. So let's start it. The process table and the process control block. In the Linux, the proper management and the control of the process are the integral component of the efficient system functionality. In this piece, we will examine two essential facets, the process table and the process control block PCB. We will delve into their definition, purpose, structure, and the importance in the operating system. In the Linux, the process table is a data structure maintained by the kernel that stores information about all the activities all the active running or waiting processes in the system. It is not user accessible directly, but utilities like PS Top provide access to their data. It is also known as a task table in the kernel terminology. Well, creating a process, the operating system performs several operations to identify the processes, to assign a process identification number to each process. As the operating system support a multi-programming, it need to keep track of all the processes. For this task, the process control block is used to track the process execution status. Each block of memory contains information about the process state, program counter, stack pointer, status of opened file, scheduling algorithms. The purpose of the process control block PCB. The PCB is used by the operating system to manage processes and keep track of their status. It provides a centralized location for storing information about a process, allowing the operating systems to manage process execution and termination, schedule process for execution, handle process synchronization and communication, provide process isolation and security. The next is structure of the process control block. A process control block is a data structure used by the operating system that manage information about the process. A process control keeps track of many important pieces of the information needed to manage processes efficiently. The diagram helps explain some of these key data items. The process control block. In this diagram, the structure of the process control block, the data structure used by the operating system to manage. The component of the process control blocks are the pointer, process state, process number, process counter, register, memory, limit, list of open files. First point of the process control block is the pointer. So what is a pointer? Pointer is a stack pointer that is required to be solved when the process is switched from one state to another to return the current position of the process. Then second state of the PCB is the process state. The process state is store the respective state of the process. Then third is the process number. The process number. Every process is assigned a unique ID known as a process ID or a PID, which stores the process identifiers. Then fourth is process counter. The process counter stores the counter which contain the address of the next instruction that is to be executed for the process. Then next is register. The register is in the PCB is a data structure when a process is running and its time slice expires. The current value of the process if a specific register would be stored in the PCB and the process would be swapped out. When the process is scheduled to be run, the register value is read from the PCB and returned to the CPU register. This is the maintain the purpose of the register in the PCB. Memory limits. The field contain the information about the memory management system used by the operating system. This may include the page table, segment table. Then last is a list of all file. List of all the file. In this information include the list of all the file opened by the process. Then next is the process control block and process table diagram. In this diagram, the relationship between the process table and the process control block. The process table contains process identifiers and a pointer to their corresponding PCBs, which stores the detailed information about each process. The diagram shows three PIDs, PID 1, PID 2 and PID 3 in the process table. The PID 1 and PID 2 having a corresponding PCBs that contain additional information. The text accompany the diagram. The diagram explains the PCB various fields including a PCB register, memory limits and a list of open files which are essential for managing processes in the operating system. The next is important of the process table. Managing CPU scheduling. The process table helps the operating system to manage CPU scheduling by storing information about each process such as its priority, state and a CPU uses. The next is a keeping track of process state. The process table keep track of the state of each process including its current state, for example running, waiting and zombie, and its memory allocation. And third is a performing context switching. The process table enables the operating system to perform context switching efficiently by storing the state of each process and restoring it when needed. Then last is a handling inter process communication. The inter-process communication in the process table facilitates inter-process communication by providing information about the processes that are communicating with each other. And then in the summary, the process table and the process control block PCB are the important for managing processes in the operating system. The process table keep a list of all the active processes and the PCB hold detail about each process. The process control block or PCB enable smooth process switching, effective multitasking and efficient resources allocation. While there are some memory or processing power, they are essential for running multiple tasks smoothly. So thank you.